So, same problem as before, but we'll make our x-axis up the ramp, or up that incline, and our y-axis, of course, will be perpendicular to the x-axis. And the real danger here is that our golf ball, we know its acceleration is going to be 32.2 going downwards. But because we've chosen to tilt our x and y coordinate system, this 32.2 will have a negative y component and a negative x component, an ax and an ay. And we're used to ax being 0 in our projectile motion problems. Yeah, we're really just used to setting this term to 0, but not the case here. We can clearly see that we have an x component of our acceleration vector. So we need an angle here so we can break down this right triangle to find ay and ax. I'm going to draw just a imaginary horizontal line here. Now I'm going to remember that our x-axis is in the same direction as that incline, which makes this angle here 10. And now I recognize that my positive x-axis and my negative y-axis form a 90-degree angle, which means this angle right here must be 70. And then focusing on my horizontal axis and like a downwards vertical axis, there's another 90-degree angle, which means that this small angle that we're really looking for is actually 10. So we can get ax by doing the hypotenuse, 32.2 times the sine of 10, because ax is the opposite, and ay is the adjacent, so we'll do 32.2 cosine of 10. Alright, so we'll put those numbers in here. Of course, at times equal to 0, my x-coordinate of 0, golf ball is right here. Same for my initial y-coordinate. And for our initial x and initial y components of velocity, I see that I have this is my x component of velocity, and this as my y component of my initial velocity. And that's just a right triangle over there based on that angle of 45. So Vix will equal 80 cosine of 45, and Viy will equal 80 sine of 45. Alright, so we'll just throw all these numbers into our equations here. So just make sure you put a negative on that x component of acceleration and y component of acceleration. As we can see here, the x component of acceleration is directed in the negative x direction, and the same goes for the y component. But our initial velocity components are in the positive x and y directions, so they can be positive. So now we can start doing our math. We know at this impact site, our golf ball is at a y-coordinate of 0. That golf ball is perfectly on that x-axis, which makes its y-coordinate of 0. So we can throw in 0 in for the y, and we can solve for what the time of impact is. So if I FOIL out one of the t's, I know that at time is equal to 0, our golf ball is at a y-coordinate of 0, and that's kind of obvious, it's not too helpful. But what should t be to make this second binomial equal to 0. So let's solve for that. So if I do my algebra, I can get that t by itself. And if I do that, we'll get 3.57 seconds. That's the time at which that golf ball impacts that incline. And last time we got 3.56, so that's good. So that is the time at which our golf ball hits that incline, and therefore all I want to do now is take that 3.57, plug it in for time in our x equation, so we can figure out the x-coordinate of our impact site. And really that's what this d distance is. Since we've tilted our coordinate system, the distance that they want is merely the x-coordinate of this golf ball at the time of impact. So I'll just put 3.57 in for t here, and we'll have our answer. And if we do that math, we'll get 166.2. And last time I think we got 165.9 or something. So I'm good with this answer. So it gets a little bit tricky doing these inclined projectile problems. Make your choice. Would you rather tilt your x and y axes? And then you have to deal with that acceleration vector, breaking that up into components. Or you can keep the normal x and normal y axes, and you'll just have to do a little bit more math. So I hope this video made sense. If you have any questions, please leave them in the comments.